clap. And this is Expert Fonda and you are watching on YouTube. So today we are tackling a fantastic bandage search plus a greedy problem from Leetcode 2171, maximum number of tasks you can assign, right? And this one's a great mix of logic and optimization. So we will break it down step by step. So let's dive in. So as you can see, the statement is saying that you have n task and m workers, right? So as you can see the example, we have given task and worker in an array, and like this is saying with a ith task requiring task at I a strength to complete, and the strength of the each worker is stored in a worker also. So this is task and this is worker, right? And we have given pills and a strength. Okay, so you pause this video and go through the statement, right, so that you will understand, right? So let me continue. So each worker can only be assigned to a single task and must have a strength greater than equal to the strength of the required, right? Means that the worker can implement the task, right? Worker can complete the task if they have the enough strength. Like worker at J should be greater than equal to the task, right? Either it should be greater than or equal to. So this is the strength we have given for the worker, so he can finish the task if and only one if it is greater than equal to the given length at I and J, you can say. Okay, so additionally you have a pills, magical pills that will be increase a worker strength by a strength. So if the given number of pills are there, so he can take the pills of a strength, and if the strength is enough for the worker to finish the work, then we can finish that work. Okay, so our task is to return the maximum number of such tasks that is completed. Okay, so what is the problem intuition we have here, right? So what you have to do, you have to understand, imagine you have a set of tasks, right, and each needing a certain amount of strength and a bunch of workers. So each with their own strength level. You can also hand out limited number of magic pills that boosts a worker's strength by a fixed amount of the strength, right, you can say, and so he can finish the task. Okay, so your job, what is your job? Your job is to assign as many tasks as possible using these resources that we have given here as here, right? So there is many examples are there, you can go through here, right? You can pause this video from here and you can go through there, so you will understand what is the intuition of the problem is here. Okay, so what I understand from here, right, and you can relate it as much as possible, right? So the intuition is like a strong worker should ideally take on hard task. You got the point? Means the strong workers should ideally take on hard tasks. Let's suppose this is 3, right? So who is the you can say stronger worker, right? So these are the workers, these are stronger. Okay, right? And if you observe the example 3, right, in this case who is the strongest one? So to complete 10 there are 4 guys are here already that are enough to finish the work, right? But in this case if you see, the worker strength is 0 and he should finish 5 and 4 tasks, right? But they doesn't have the strength. So if the first one, if we'll take the one pill of a strength 5, he can finish the first work, right? Like that you have to think. Means the here doesn't have the enough examples, but you can think like what is the intuition here. So intuition is to find the stronger worker should ideally take on hard task. That's all, right? And the pills should only go to the worker who just barely need them. For let's suppose we have 3 to 1, right? Let's suppose we have 3 to 1. Okay, and if we are going to give this pill to these two, right, these two workers, means there's no benefit of that, right? So if we will use the pills of strength here for this worker because it's barely need them, right? So if we'll give this a strength to this worker, he can finish this work, right? And so the 3 and 3 can be finished by these two tasks, right? These two tasks can be finished by these two workers, right? Means the pills should only go to the worker who just barely need them. So don't waste them on workers who still can't do hard tasks even with a pill, right? And so we will use binary search to try assigning these k tasks. Let's suppose these are the k tasks, right? So we will use binary search to try assigning k task, and we'll check if it is feasible or not, right? So what we will do, we will do the step by step coding, right? So you can understand here, right, that I have done already, right? So let's break this down step by step to understand the code, right? So what we should do, let me go through the task here. So first of all, see the given things, right? So as I told you, we have given these things already in the example, and with the same things we have to return the number of what you can number of the completed number of tasks, right? Maximum number of tasks. Okay, so first of all, what we should do, we should we should sort these tasks and workers first, right? Why? So we can pair the hardest task with the strongest worker efficiently, right? So let's suppose if this is in the sorted order. So if this will be the sorted order, what will be the task? 1, 2, 3, right? And what about the worker? If we'll sort this will be already sorted. Let's for example, for this example, so 0 will get assigned to 1, and so the 0 worker needs a strength of one pill, and he can finish that work, right? So it will be easy for him. So why we are sorting this, right? So why we are sorting this? Because if we will sort the task and workers, right, so we can pair the hardest task with the strongest worker efficiently, right? That we have understood. Okay, now what we should do, the next step is to uh, do the binary search on the number of assigned tasks, right? So the first step, we will do the sorting, and the next step, what we will do, we will do binary search on the number of assignable tasks. Okay, so the range is from 0 to minimum task, right? So what is the range? The low index of the array, if you remember the binary search, right? Binary search used to divide the searchable array into half, right? And if we find the searchable on the mid, we used to return the mid. Otherwise we used to move the low, will move to the mid plus 1, means half we will discard, and half we will half we will discard, right? If we will find at the mid, means we will return the result, right? Like that. So the binary search here on the number of assignable tasks, and so the range will become what? From 0 to the 0 to mean task of mean task, you can say mean task, right? The task length and the workers length will become the mean, means low and high, right? So low will be 0 and high will become what? High will become what? Minimum between the length, minimum between the length, task length and the workers length. What is minimum? That we will take. Why we are talking about? Let's suppose if we have task is 3 here and work is only 2 worker is there, means the high will be only 2. You got this point? Let's suppose the task is here 3, right? But the worker is only 2. This 0 is not there, or 0, 3 is there, right? So the task length will be 3, but the worker length will be 2. So the high will be 2, right? 0 to 2. We will go maximum 0 to 2. Which is minimum? That that we will take, right? And so we will return the result once we will get it. Okay, now we'll go with the low is less than equal to high, right? And for that we will create this while loop, right? And we know how to find the mid in the binary search. To low plus high minus low by 2, we'll get the mid. We'll check the condition, these two condition, if and else, right? Means we'll assign, can assign on this mid the task fields and this strength. Will, if we can do that, if we can assign that, we'll assign the mid at result. Otherwise we'll update low, we will discard the half of the array will discard, and we'll move to the mid plus 1. And if this is not the condition, right, then we'll return, then we'll go to the else condition. We'll discard the second half, we will discard. This is the first half we are discarding, and this is the second half we are discarding. Okay, otherwise we'll update the result. So what is this can assign, right? So we'll create a greedy check function, right, can assign, and we'll pass a k. Let's suppose, what is this? Sorry, so from here to here is nothing but, you can say k, right? So k is the hardest task, you can say, right? We can provide the hardest task, and then we'll check can we assign this hardest task to this guy. If yes, we'll find the result, means the number of completed tasks, right? That can be computable. Okay, let me expand this. Okay, so now you can see here we have the another task, the can assign, right? So for k hardest task, right, for k hardest task, as you can see, right, we have used here k hardest task, right? So for the k hardest task, like we are calculating the mid here, right? So k hardest task, what we have to do in this greedy function, the first of all we should try to find a worker who can do the task, right? And if not strong enough, then check if using up pills helps, right? So use the smallest available worker with pills to conserve stronger workers, right? Means first we will try to find the workers who can do the task, right? And for that we will write this piece of code. Means we'll create a available q, right, dq you can say, and j will be m minus 1, right? And what is m? The m is the worker's length, and p, you know, the pills, right? So we will create a for loop, right? And we'll go through all the workers. For all the workers, why? Because we have to find a worker who can do the task, right? So we'll go through the workers, right, in the decreasing order. Okay. Through the while loop, we'll check the strength. If the workers at j plus the given strength is greater than equal to task at I, if it is, in the reverse order we go, right? Why we are going the decreasing order, right? Because if we have this worker, right, so the strength that we have given will go through like this, so that we can find the workers at j, right, is having the strength or not, right? If the strength is there, and then we are doing j minus minus worker at j minus 1, so we'll keep decreasing here, and we'll have our highest strength will be this side, so we can find the available worker, right? Means we are trying to find a worker who can do this task. So you can do like this. So available will get add first this one, and so this while loop will continue, we'll keep checking the strength, and we'll keep adding who can finish this work, who can complete the task, right? If available is empty, return false, that we cannot assign that this task, because the worker doesn't have enough strength to finish this work, right? Then we'll check if at the available we have something, right? Means some workers is already there, so we can get from the peak, right? Peak we will get from the peak, and we'll check the task we are able to finish it. Yes means we'll remove from the available. This worker has finished that work, we'll say. If not means it is not available there, but we have, if p is equal to now means the pills are no more, pills has been finished, so we return false. If pills, we have enough pills, right, then we'll go to the next step at line number 36 and we'll decrease the pills, right? Then we'll do again the pills poll first, we'll remove the available, and we'll keep continuing that for all the given task, you can say, right? Or worker, you can say, right? Then we'll return true, means we can assign or not, right? There is only two cases: if there is not available enough workers, or if there is no available pills, then we will return false. Otherwise we can assign the task. If we have available workers, we can add that. If not available, we'll return false. If it is available, we'll do minus, we'll pull out. And if it is there but the pills is equal to 0, we'll return false. Otherwise we'll return pills minus minus, and then we'll do false out. And finally we'll do that and we'll return true. Okay, so so the main thing about this method is to assign the task, right? We have to find the worker who can do this task, and if not enough if not enough strength, right, then we'll check if we can use a pills to help him to finish the work, right? So we will use the smallest available workers, right, and with the pills to conserve the stronger workers. Okay, right? So time complexity will become what? O of n log n plus m log m, because we are doing sorting here. As you can see, we are doing sorting here, right? And for the sorting, right, we will use n log n plus m log m, right, because we are taking two arrays, right? And like and for binary search, right, O of log m will take mean of m and n, which one is minimum, that will take for the binary search. And we'll check O of k with the efficient dq, because we are using the dq here, right, and for each operations. And so we have extra spaces that we are using here in the worst case for O of k for the dq in the worst case, right? So the complexity we'll talk about, it will become what? So this will be your time complexity, right? And for the binary search, you will be taking the dq, right? And for that, how many k we have, that will take, right, for each dq operations, right? And space will also take O of k. Okay, now it's time to understand the code step by step. Okay, so I told you to first what we will do, we will do the sorting, right? So we'll do the sort of task and worker. So we will do, right, why we will do that? To find the binary search, right? So we can pair the hardest task with the strongest worker efficiently, right? And so we will do arrays dot sort task, and then arrays dot sort workers we will do. Okay, and then we'll do the binary search on the number of assignable task, right? So to do that, we have to find the low and the high. How we are going to find the high? Means low will start from 0, because you know the binary search template, right? We'll start from 0 and we'll go the high, either, right? So low to high, right? And high will be the minimum is if task is, let's suppose, 1 2 3 and worker is only 3 not 0. All right, so means only 2 worker is there and 3 tasks are there, right? So we have to go with the minimum one, right? So the range is from 0 to mean of task dot length and workers dot length, means task length and worker length, whichever is minimum, that will be our high. Okay, so for each midpoint k, we'll check if it is possible to assign k task or not, right? So that we will understand further, so you can understand. So we have 3 2 1 as a task, then we have 0 3 3 is a worker. Once we will do the sorting, we'll get a sorted task like 1 2 3, and worker will be 0 3 3. It will remain like same. Okay, so the sorted task now is 1 2 3 and the sorted worker is 0 3 3, right? So who needs the pills, right? As you can see, the pills required to complete this task of this worker, right? So we will add one here and will now the strength will match, and so he can finish the work. Now 3 has enough strength to finish this work, and 3 has equal strength to finish this work. Okay, so now these three tasks can be done. Okay, now it's time to understand the binary search on the number of tasks. So what are the number of tasks? We have given the number of tasks 1 2 and 3. So these are the tasks, right? And I'm saying that will the low we will set 0 and high we will find the minimum is mean of the number length of the task and the length of the worker. So length of the task and the length of worker is 3, right? So to find the number of tasks that can be completed, right? So now you can find the k is equal to 1 2 or 3, right? So you will be surprised what is the meaning of low that we are taking as a 0, right? Why we are not taking from 1? Just think why. Pause and just think. So there is a catch, right? What is the catch? Like you will say that low at 0 and high at 3. Okay, so but the range you are saying is what? 1 2 3, 1 2 3, right? So there is a catch, right? And your question is right. Okay, so in the max task assign a function, like for the binary search, this is the main function where we write the binary search, right? And the range is actually, so the max task sign we have a low and high, right? So low we are taking 0 and high we are taking 3 comma 3, and this will become minimum of 3, right? So that's the problem here. Like we are saying the range is 1 to 3, right? Means so the range is actually low at 1. Low is not at 0, it should be at 1, right? So no, actually not, the range is not equal to not from 0 to 3, it's the range is equal to 1 to 3, right? So technically why low is at 1 and not the 0? Because we are trying to find the maximum number of tasks we can assign, and we are saying k, right? We are saying k. So at value k at 0, at value k at 0, no task assigned, right? Right? And it's a trivial and always valid, right? If we are talking about no task assigned, means we don't require this thing to say that, right? It's just a trivial and it's always valid, because this is binary search and this is about the template to talk about, right? So we start searching from 1 to the mean of this. Means we will start from, there will be some task, right? So we'll start from 1, then we'll start from 2, and then we'll start from 3, right? Means we start searching from 1 to mean of m and n, and m and n is 3 comma 3, means 3. So the maximum number of tasks that could be possibly will assign is between 1 to 3, right? So what does mean 1 and high is 3, right? So the task we have given is 3 to 1, right? So this is sorted 1, okay? And the worker is 0 3 3. So n is what? N is 3, m is 3. So minimum is 3. And so the low is 1 and high is 3. So we do binary search to find the largest k task that we can assign, right? Is can assign, right? And this k is 3, right? So we'll pass the 3, right? We will pass the 3 and we'll find the, like, how many tasks we can assign it, right? Number of tasks is 3, right? And can we assign 3, right, to any of the worker, right? So this is why I'm telling the correct binary range is we will start from the left one, right? You can start from the 0, that's not problem. 0 you can say, the left will be at 0, not about the 3, right? So left is at 1, not at a 0. So you can assume 0, but there will be no problem, but it will start from 1. So we are not interested in assigning 0 task, right? So assuming 0 task is trivial and that is always possible. So our goal is to maximize the number of tasks we can assign. So the actual range is what? 1 to 3, right? So this is why the confusion happened, right? The confusion can be happen, and in many binary search templates, like for lower and upper bounds, we start from 0 to high, and that includes 0, right? But in this problem, we are searching for maximum number of assignable tasks, right? And so the starting from 1 makes more sense and avoids pointless can assign 0, right? Can assign will pass here 0, right? And that is I think you can say pointless things, right? For now, if you put 0, that is no problem, it's a trivial and it's always valid. Okay, we continue ahead, and then we'll talk about, so what we have to do in the binary search, we'll do sorting. So after the sorted, you will get like this. Then we'll check the pills. We can whoever needs pills, that we will provide the pills, right? And in the binary search, the range will be 0 to 3, and the value of k will be 1, 2 and 3, right? So to find the maximum number of task k, we want to find the number of task k we can assign to the worker, and for each worker that can be at the most one task, at most one task, we can use up to pills to boost the worker by the strength. So if the range is between you can say n and m, so max k value will become what? Is 3. So max k is 3. Okay, now think, now let's iterate the binary one, and then we will move ahead. Okay, so assigning k equal to 3, it means we will use the greedy checks function now, and we try to match the 3 hardest tasks, right? What are the hardest tasks? 3 to 1 with the available worker 0, 3, 3. So we'll use a DQ to track the eligible worker, and we can say, can we assign 3 tasks? We will check for the hardest task 3 to the earliest, and we'll try to assign a worker using a greedy approach. So how we'll do that? So let's suppose we have iteration 1, and we'll take a task equal to 3. Okay, so task equal to 3 is, we are going for the because we have written the code, right? So we are starting from here, means the highest one, you can say the toughest task. So 3 will check if we have any worker who can do the task is equal to 3, and yes, worker 3 can finish this work, right? And he has enough energy, or you can say enough strength to finish the work, as you can see in this part, right? So I'm talking about the task 3, who can do, the worker 3 can do. Similarly, we'll go with the next, we'll go with the 2, he can finish by this. Here is 0, so we can take 1 pills, and he can finish this work. So we are here. So the iteration 1 saying that task 3 we will take, and he can finish without taking the pills. Then we'll take and for that, how will it work? So the nested function that we have to check the assignable task, right? So eligible workers with the strength, we will check greater than equal to 3. I'm talking about this function. I'm talking about this function. So worker is there, strength is there, it will check greater than equal to this I, right? So what it will do, it will check the eligible worker with a strength greater than equal to 3, right? If it is greater than equal to 3, means worker having 3 value, and will put in the DQ. So DQ will do in the DQ will be 3, and we will assign the task 3 to the worker 3. So there is no pills needed, right? Next, at the task 2, right, we'll take task 2, and who is the worker is 3, right? So because 0, 3, 3, right? So worker is 3, and so there is no pills required to finish this work. So eligible worker strength is greater than equal to 2, yes. The worker have value 3, yes. Add to the queue. Now DQ is already, we have data 3, right? And now we are adding the that he has already finished, right? And now we have to DQ the value, right? So we'll add 3, right? And we will assign 2 to the worker 3, and so no needs to the pills, no pills is required. Last, we have task 1. So at task 1, remaining worker is 0, right? And so we need 0 plus the strength. What is the strength? 1. So yes, he can finish the work, and so we have assigned 1 pill to strength him, and in the nested function will provide check the function. He will check this, and then he required the what we can say dq we have to do, and then dq at 0 will do, and then we will use one pills to boost the worker, assign task 1 to finish this work. Like that we will do continue, and then the job is done. So final thing is will provide the task 1. The task first is 3, right? Then worker 3 can finish this work without using the pills. Then we will use 2, and then worker 3 can finish this work, and then 1, and the worker can finish this work. Okay, I hope you understand this video, guys. Let me know if you have any doubts, and thank you for watching this video, guys. Okay, so conclusion is all 3 tasks are assigned successfully and used exactly 1 pills, and so the maximum number of tasks is 3. Thank you for watching this video.